Okay, in this video I'm going to begin going through the review exercises for our upcoming test. The sections that you want to look at are 3.4, 3.5, 4.1, and 4.2. Now at the beginning of this review, I've included some problems that are slightly different than things that we've been working with, but yet have some consistent elements to them. And one of those is that we have used function notation before. For example, we have done something like g of 1, negative 1, is equal to 4. We've said something like that. But what does that mean? That means that when x is negative 1, the value of the function, or the y value, would be 4. So let's see what that means in this case. And now that is particular to this specific example. So what I'm going to do is, in place of the x, I'm going to put parentheses. That's a placeholder there for a value. And so I'm going to plug in our negative 1. So what this problem asks us to do is to evaluate each of those functions in 7, 8, and 9 when x is equal to negative 1, when x is equal to 0, and when x is equal to 4. So I've already told you what the first answer is going to come out to be, but my suggestion is, on your calculator, put the x value, wrap the x value in parentheses, just the x value itself. Everything else stays the same, and we'll see on the first one that you will get negative 1 squared is positive 1 times 3 is 3 plus 1 is 4. Second example, we want to evaluate the function when x is 0. And what is that going to come out to be? So we're going to say, let multiply 3 times 0 squared plus 1. Notice that the only thing that goes inside the parentheses is the x value that we're substituting. And we would have 3 times 0 is 0 plus 1 is 1. So g of 0 is 1. That's what, when it says evaluate the function, g of x in this case, when x is negative 1, 0, and 4, we want to find out g of negative 1 is what, g of 0 is what, and g of 4 is what. So in each case, we're going to put a placeholder there for the x value. In this case, the x value will be 4. Order of operations tells us square first. So 4 times 4 is 16, times 3 is 48, plus 1 would be 49. And so that is number 7. So let's go on and do the same thing for number 8. Number 8, we have b of x, which is, and we're looking for b of negative 1, b of 0, and b of 4. We want to find out what those are in each case. So b of negative 1 says negative 2, open parentheses for the x value, and we can do that for each of them, just leaving a placeholder for the x value. And we're going to write inside our different x values of negative 1, 0, and 4. And we'll come back. And negative 2 times negative 1 is positive 2, minus 4 is negative 2. So b of negative 1 is negative 2. b of 0 is negative 4. b of 4 is negative 2 times 4 is negative 8, minus 4 is negative 12. All right, so we'll go on to number 9. Number 9, we have absolute value of negative x plus 5. I don't need to write that. So we'll start right off with the values. H of negative 1 means negative. Again, I'll write everything where there is the variable, I put an open I put a pair of parentheses there. And I'll do that for each of these. H of 0 is absolute value negative, parentheses, plus 5. H of 4 equals absolute value negative, plus 5. And I'm going to fill in the x values that we want to evaluate the function at. Alright, so here we go. We're going to simplify what's inside the parentheses first and then apply the absolute value. So we have negative 1, which is positive 1, plus 6 plus 5 is 6, and absolute value of 6 is 6. Negative 0 is 0, plus 5 is 5, and absolute value of 5 is 5. Negative 4 is still negative 4, plus 5 is 1. Absolute value of 1 is 1. So all we're doing is finding what is the y value, or what is the value of the function when x is a particular value, such as negative 1, 0, or 4, and we call this evaluating the function for certain values of x. And we'll go on to the next. So in the next two problems, what we're asked to do is find the value of x so that f of x is 3. What this is asking is, what is the x value when y is 3? That's all it's asking. What is the x value when y is 3? So on the first graph, I look for y equals 3 on the graph, and there it is. What is the x value? The x value is 2. I would simply say x is equal to 2, or I can write it in function notation, 2 comma 3, or the coordinates or function notation would say f of 2 is equal to 3. What is the value of x when y is 3? The value of x is 2 when y is 3. Alright, so let's go on to problem number 11. Same thing, we go up to 3. There is y equals 3, and we can see that x is equal to 1. We have the point 1 comma 3, or in function notation we would say that f of 1 is 3. So find the value of x so that f of x is 3. We'll go on to some more examples. Okay, so what we're asked to do here is to find the x and y intercepts of the graph of the linear equation. How do we find the x and y intercepts? Recall, for the x-intercept, that's where the graph crosses the x-axis, we know that y is always equal to 0. And so we have the point something comma 0. Now when y is equal to 0, then we can cover up the y term, and we end up with 2x is equal to 6, divide by 2, and x is equal to 3. So in this case, the x-intercept is 3, the y value will be 0. For y-intercept, x is equal to 0, and this time we will cover up the y term, x is equal to 0, so we're going to cover up the x term, and when we do that, we're left with 3y equals 6, divide by 3, and we get y is equal to 2. So when x is 0, y is 2. So the x-intercept is 3 comma 0, the y-intercept is 0 comma 2. If we were going to graph these very quickly on a graph, x is 3, y is 0. we'd have a point here, and then when x is 0, y is 2, and we would have that point there. Then we're simply going to draw a line through them. Okay, so we have our x-intercept, our y-intercept, and then we go on and graph them. Okay, in the next problem, we have negative 3x plus 5y. Again, x-intercept, y equals 0. That's the point something, comma 0. When we set the y term equal to 0, then we get, and I'll just cross it off here, we get negative 3x equals negative 30. Divide by negative 3, and we get x is equal to 10. So the x-intercept is 10, comma 0. Next, y-intercept means x is equal to 0, and when we cross off the x term, because anything times 0 is 0, we end up with 5y is equal to negative 30. Divide by 5, we get y is equal to negative 6. And so when x is 0, y is negative 6. So therefore, our x-intercept is 10, comma 0. Our y-intercept is 0, comma negative 6. If I were to graph this very quickly, I have x is 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you do this carefully on a piece of graph paper or on a graph on a piece of paper. And my y-intercept is 0, negative 6. 1, 2, 3, 4, 5, 6. And put a point there. And then all I would need to do is draw the line through the 2 points. All right, we'll go on to the third example here. Now, in this case, again, we have x-intercept, y is equal to 0. We'll have the point something, comma 0. When we set the y term equal to 0, we get 1/2 x is equal to negative 8. And remember what we do here. We will multiply both sides by 2. And that will get rid of the fraction. We will have x is equal to negative 16. So negative 16, comma 0, that's our x-intercept. The y-intercept, x is equal to 0. And this time, y-intercept x is equal to 0, and we simply get y is equal to negative 8. So we'll have the point 0, comma negative 8. All right, so if we were to go ahead and graph that, this might be a little difficult because we have such big numbers here. We have negative 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, somewhere way over there. We could also number them by 2's, that would be fine. And the y-intercept is going to be negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. Put a point there. And we would draw a line through them, and we would have our line there. So all of these are in standard form. Remember, that's ax plus by is equal to c. And this is very useful when graphing. We find the 2 intercepts, we plot the points, and we stop there. All right, so that's going to be it for this video. We'll go on to some more examples in the next.